Welcome to the another video of the electric drive. Here we will focus on some of the useful load torques, and we will take in general 5 different type of load torque. One is here, let us say in the x-axis we have torque, and in the y-axis we have omega m. So let me draw 5 different axes first. So here I have mentioned the 5 different curves here, A, B, C, D, E. In the first one, we will have some type of curve like used in the fan, compressor, like water pump, where usually if the speed increases, the torque required is initially very less. Gradually that get increase like this, and such type of speed torque characteristics can be told as TL is proportional to omega m square. So here we can say that it is like y is proportional to x square, where x is in the y-axis and this t is proportional to x square, so it is like hyperbola, not hyperbola, it is like parabola. So the second type of curve will be for the low speed hoist. Hoist is just you have a motor and a wheel so that you can lift a mass either up or you can put it down. Low speed hoist. This type of load is having a fixed load torque because the load torque is only because of the gravity, mass into m into mass due to gravity due to mg. So this is the TL, which is a constant, especially for the low speed hoist. And if the hoist is a high speed, if it is a high speed, in that case the torque is there, no longer the torque is there, but this torque, if the speed will increase, will not be the constant, rather this will, there is a exponential, there is some linear rise in the speed. So the curve will be look like somewhere like this in case of high speed hoist. Right. And another case is there using a traction load. In case of traction load, usually the load is very heavy on railway track. Then when its static friction is very high, and then once it rolls, the torque is less. Then further, if the speed is normal, then we have a little bit of torque is required. However, if the speed is very high, then the torque requirement will be much more. So this is how the traction load speed torque characteristics curve. Another one is for a coiler type of drive. Coiler type of drive means roller is there, coiler is there, and it's like pulling a rope, pulling a wire at a constant speed v. So here the velocity is to be constant. The force with which this is being pulled is a constant. If the tension is more or less, so there is a chances of getting cut of this wire may get cut or bulk will be there like that. So the power requirement has to be constant over here. So if the power requirement is constant, like this case, another case is that suppose we are using a drilling. drill or a wall is there and you drilling it, right? So when you are using a driller, so when the drill is inside the wall, the speed has to come down. So if the speed is now omega 1 and after it get into it, its speed is 2, the omega 1 should be greater, the omega 2 should be lesser. So, and also when it is drilled inside, the torque is very high required. When it is outside, the torque requirement is less. When it is inside, the torque requirement is more. In other way, what is the objective is T1 into omega 1 is equal to T2 into omega 2. That also says the power to be remain constant. Such type of drive required when the speed is high, the torque is less. Another point is when torque is high, the speed is less. So we can have a hyperbolic curve. Y is like T is inversely proportional to omega m. So in this type of speed torque characteristics we can have for such type of load.